Welcome to a presentation of the Newtons4th PSM 1735 Frequency Response Analyzer. In this presentation, we will use the PSM 1735 to make Bode plot frequency response analysis of a switch mode power supply control loop. To make this test, we will inject a disturbance signal across a low value resistor that we have placed into the output feedback chain of a switch mode power supply. And we will analyze the signal either side of this injection resistor. If we now switch on the instrument, there will be a power-up routine. Then the default measurement screen will be presented, showing RMS voltage measurements on each of the PSM 1735 measurement channels. Here you can see 4.99 volts, which is predominantly the DC voltage on one side of the injection resistor, and 8 millivolts, which is the AC component, and happens to be measured on the other side of the injection resistor. The PSM 1735 is a true wideband RMS instrument, so we have AC, DC, dBm peak, crest factor and surge measured for both channels. The channels can be voltage measurements, which is the default mode, or become current by virtue of shunts for different applications. In this case, however, we're just looking at voltage. We're going to set the AC coupling mode for channel 1 by going into the channel 1 menu, because for frequency response analysis, we're interested in only the AC component. Now you see 1.6 millivolts on channel 1 and 8 millivolts on channel 2. Channel 1 is the input and channel 2 is the return. So there is gain. If we now go to FRA mode, we can see that we have gain of 26 dB with 71 degrees phase angle at the injected frequency, which happens to be 100 Hz. This injection frequency can be changed during a sweep, but what we want to illustrate is that the gain phase plot is dependent not only on the frequency and injection signal level, but also the load of the power supply. We presently have a load on the power supply which, if we remove it, you will see a change to the gain phase values. So this has now changed to 13 dB, and if we switch the load back on, the gain returns to 26 dB. It is therefore clear that the loop gain at a single frequency point is influenced by load change. Normally, however, loop response measurements are made over a frequency sweep, so we will go into a sweep menu, where we have preset a frequency range of 30 Hz to 30 kHz. This range can be set to any frequency range from 10 microhertz to 1 megahertz in the PSM 1700, or 10 microhertz to 35 megahertz in the PSM 1735. We have selected 32 steps for the sweep, log plot, and a single sweep. If we now come back to the measurement mode and press start, you can see that the frequency is stepping up and the values of gain and phase are changing. If we go to table mode, we see the table building. And if we go to graph mode, we see the graph building. This is the gain graph, and if we press the graph button, we get the phase graph, and if we press again, we get the gain and phase. You will also see on the top of the graph automatic gain phase margin calculation. This interpolates a cross point to make sure we get zero crossover, even if the sample points don't intersect with the zero. If we now change the load, you can see by a resweep with a different load that the plot will change quite considerably, which illustrates the significance of load change to control loop analysis. The measurement we just made was the standard speed. If we now go to the acquisition menu, we can increase the speed from medium to fast and run another plot. This enables engineers to make tests easily and quickly during the development of a control circuit, and then return to standard speed for a more detailed analysis. These measurements can be stored inside the instrument, recalled later, and output to a PC for analysis in a PC. Or the instrument can be controlled directly from a PC with data going to the PC display. We have in the internal memory a previous sweep measurement saved. To illustrate this, if we go into the Program menu, we can recall programs, data logs or sweeps, and if we recall a sweep we have made recently and select Execute, you can see that the program is loaded, and that can be compared to other plots or exported to a PC. Thank you for watching. We hope you found this presentation useful.